Hi everyone, and welcome to this lecture. So here we are going to see how we calculate the rate of hypermutation. As we've seen previously, this rate of hypermutation is inversely proportional to the affinity. So let's suppose that here we have two antibodies, and here in the middle we have an antigen. This is an antibody with 60% affinity, and this is an antibody with 80% affinity. If they need to suffer mutations to better optimize their affinity with the antigen, which one of them needs more mutations? Because this antibody only has 60% affinity, we need further improvement. We need more improvement than in this antibody right here. So this antibody might suffer more mutations. And here we have the formula to calculate the hypermutation of a specific antibody. We have to say again that the rate of the hypermutation will be calculated based on the affinity of the antibody. So here we have hypermutation for antibody K in iteration I. Here in red we have the affinity of antibody K in iteration I, and beta is the mutation factor. We can choose 0.1, 1, 10, etc. So the formula is 1 minus the affinity of the antibody divided by 121. Why 121? Because in the specific problem we are working on, 121 is the best score, multiplied by beta. Let's see some examples. Let's suppose that the affinity of a certain antibody is 79. Beta, the mutation factor, is 0.1. Therefore, the hypermutation will be 1 minus 79 divided by 121, everything multiplied by 0.1. It should be noted that 0.1 is multiplied after everything has been calculated here, and the result is 0.0347, which means that each component of the antibody has a chance of 3% of being mutated. So let's suppose that here we have an antibody. It means that we have roughly 3% chance to change this 0 to 1, 3% chance to change this 1 to 0, and roughly 3% chance to change this to 1. Let's see another example. Let's suppose that here the affinity for this second antibody is 110, and the mutation factor is the same. So here we have 1 minus 110 divided by 121, and after we perform this subtraction, we multiply by 0.1. So the rate of hypermutation for each part of the antibody is 0.009 or 0.9%. It means that if we have this antibody, we have 0.9% of changing this 0 to 1, of changing this 1 to 0, and of changing this 0 to 1. So this was a lecture about the calculation of the hypermutation rate. I see you in the next lecture.